Welcome to Elimu TV, a place where you watch and learn. I am teacher Alex Musawa and I'll be taking you through physics form 1, lesson number 33. Our title is Connecting of Cells in Series and in Parallel. The objectives of this lesson are to find out the difference between cells connected in series and parallel. The first is you're going to look at cells connected in series. When cells are connected in series, the negatively charged part of the cell is connected to the positive terminal. You can see the negative and the positive terminal are connected. The same continues. And so, how do we calculate the total volts or the total EMF? Is the EMF of cell 1 from the diagram, as you can see, plus the EMF of cell 2 plus the EMF of cell 3, and the pattern continues. The resistance is the same. When cells are connected in series, we assume it is as though resistors that are connected in series. And how do we calculate the resistance of resistors connected in series? It is just the same. The resistance of the first resistor, R1, plus the resistance of the second resistor, R2, plus the resistance of the third resistance, R3, and the pattern continues. Cells connected in parallel. When cells are connected in parallel, the like terminals are connected to each other. For example, the positive terminal of the battery is connected to another positive terminal of the battery, and the pattern continues. The negative terminal of the battery is connected to the negative terminal of the battery, and the pattern continues. So, for example, let's assume that the cells are resistors. It is the same. How will you calculate the resistance of the circuit? If you are going to take the resistance of the first cell, so it is going to be 1 over R1, which is the resistance of the first cell, plus 1 over R2, which is the resistance of the second cell. And as we add them, and we are going to find the reciprocal, which will give us the total resistance. Next, we have bulbs connected in series. What can you see from the diagram? When bulbs are connected in series, the positively charged terminal is connected to the negative charged terminal of a bulb, and then negative terminal is connected to the positively terminal of the bulb. That is the diagram in a laboratory. Those are two bulbs. You can see the bulbs connected in parallel. Those bulbs are connected in parallel. Next. So, what happens? Let's compare two circuits of bulbs connected in series. We have two bulbs there. The first part is the bulbs are connected in series, and the second one, the bulbs are connected in parallel. The bulbs connected in series, they are dimmer. Why are they dimmer? It's because the EMF of the cell is shared in between the two bulbs. That's why the bulbs appear to be dimmer. Number 2, there is less voltage across each bulb. And number 3, there is less current that passes through each bulb. Let's look at the parallel circuits. The bulbs are brighter. And why are the bulbs brighter? Is because the EMF that passes through one bulb is equivalent to the EMF of that passes in another bulb. It is as though the total EMF of the circuit is passing through one bulb. That's why the bulbs are brighter. Number 2, there is higher voltage across each bulb. And number 3, larger currents pass through each bulb. And that is the end of our lesson. I have an assignment for you. What is the difference between a circuit with cells connected in series and cells connected in parallel. The reference book that we have used in this lesson, we're going to use KLB Book 1, 5th edition, 2019. For more information, kindly contact us on our SMS number +254 723 144 259, YouTube Elimu TV, Facebook Elimu TV, and finally Twitter at Elimu TV_KE. Thank you for watching Elimu TV. Stay tuned.